You are required to understand and implement the safety guidelines listed below. Your instructor may also include additional safety practices. Perform laboratory work only when your instructor is present. It'll usually be locked if I'm not, but if it's unlocked, don't come in unless there's an instructor or some type of lab manager, things like that. Your instructor may also introduce additional rules. We said that. Okay, so unauthorized, unsupervised lab experimentation not allowed. Rule 2. This is the big change. 2 and 3. In the past, we were a lot more lenient, and I'm going to tell you why. We're going to do this really, really fast. I'm not dwelling on a lot of conversation. There were a number of people in the biology department who wanted to require us to have lab coats because some of the other colleges are requiring lab coats. And there were a bunch of people who said, yeah, we don't want that because that's an extra expense we don't think the student should have to take. Shouldn't have to do that. So what they came up with was a compromise. And the compromise is we want your backs covered, your midriffs covered, we want your legs covered, especially down to below the knees, hopefully down to the ankles. We want your shoes covered. That way, if you are in the lab, there's less chance of getting nasty things on you. Now, this class usually isn't bad about that anyway. But the whole idea was if we adopt this, maybe we can hold off making people buy lab coats for at least a few more semesters. Does that make sense? So that's the reason for this. But here are the rules. So you're required to wear safety goggles and glasses as directed during lab sessions that use chemicals or hazardous materials. We don't have much of that. We do, of course, do sections, and there is formaldehyde, and if you want to wear goggles during that time, it might be a good thing. We used to have loaner goggles, but a couple of semesters ago we got rid of that. They started telling people they had to buy their own goggles and buy their own gloves, but then we had the COVID thing, lockdown. We had a whole bunch of gloves that because things were online, we weren't using, so we started giving gloves away for free. So right now, the short version is somebody emailed to remind me, and I will check with the lab manager what they want to do about 2. But I think they're going to want you to buy gloves and goggles. But gloves, at least, we have some here. Good? All right. Now, 3, this is a big change. Wear sturdy, closed-toe shoes that cover the feet in their entirety, the top, the heel, and the toes. Heel is new. No sandals, flip-flops, or Crocs. Wear a shirt that covers the torso. We're talking about the back, midriff, the shoulders. I had 2 people with uncovered shoulders yesterday. That's a little if, yeah, okay. Shorts or short skirts are not permitted. Wear long pants or a long skirt with no rips, tears, or mesh. Pants or skirts should cover the legs to the ankle. Long hair must be tied back. Get the band-aids out, tie it back. Oh, okay, you got it covered. Anybody else need a hair tie? Okay, that's easy. You good?
This is considered long.
Yeah, it's long enough.
Yeah.
All right, if you think this is a stupid rule, I will tell you that I know it's annoying to have to tie your hair back all the time to go to the lab, but I also know firsthand that the smell of human hair in a Bunsen burner is not nice. I used to have hair down to here when I was a student, so yeah. All right. Anyway, and yeah, I've had lab things where I took all the hair off one arm. Explosion. But we'll talk about that later. Okay, so you got that. We're trying not to do stories. You want to eat, drink, chew gum, store food, or apply cosmetics in lab. That is not an exaggeration. We do not want that at all. Why would you not want to apply cosmetics in this lab? You share it with microbiology. Do you want E. coli trapped between your lips and the makeup you put on, and then you go to kiss your significant other and you're spreading butt bacteria on their face? I bet they don't want it. Clear? Good? All right. All right, let's see. Never taste chemicals. Smell chemicals only when directed by me, by cautiously wafting the vapors towards you. Let's talk about that. I heard a giggle, and that made me giggle. But in the 60s, that was a thing. This rule exists because the lawyers wrote that rule. They want us to keep it. Back in the day, the way you moved chemicals or cultures of live bacteria from one container to the other container, we had these things that were called mouth pipetters. Basically a long glass tube, like a straw, with a bulb in the middle, a big bulge. And so you would suck till you suck the stuff up the straw until it's filling the bulb. Once you get to the top of the bulb, you better stop or you're going a mouthful of stuff. You go to the next container, blow to put it all down in there. Now, if you think, well, that sounds like they probably got a mouthful of bacteria, a mouthful of nasty chemicals, you are right. That's why we don't do that anymore. I don't ever want to see anybody mouth pipetting. I don't want to see any mouth pipettes brought in. If you bring one in as a joke, I will smash it and put it in the broken glass container. This is not an exaggeration. Is that clear? Okay. If you wonder what it's like, you've probably seen somebody trying to siphon gasoline. So they go from the car to the can, take it to the other car, and they get a mouthful of gasoline. Yeah, imagine nastier chemicals, nastier things than that. And nobody enjoys the car thing. You've seen that. Anyway, so no mouth pipetting, no tasting chemicals. Smell, where it says cautiously wafting the vapors towards you. What are they talking about? Say you have two chemicals, two containers, carboys, and you're like, which one is the acetic acid? Which one is the hydrochloric acid? You open this one. Oh, that smells like vinegar. That's the acetic acid container. Now put the top back on. No, that smells like pool cleaner. But it is. That's hydrochloric acid. Okay. Acetic acid is vinegar, or I should say vinegar is diluted acetic acid. But you would never want to do the same thing by opening the container and go, because if it was the 12 molar hydrochloric acid, you'd be, oh, that's awful. Okay. If you do this, you can tell what it smells like, pool cleaner, without entailing enough to hurt you. Does that make sense? Mm-hmm. So that's why we waft the vapors. Okay, good. Later on, if you look at the basic concepts videos, I'll probably give you guys a link to a playlist. It's real short. I have one about acids, and I accidentally cough and hack like that when I open a container of acid. Anyway, enough. Know the locations of the nearest eye wash, shower, spill cleanup. Let's go through this. All right. The eye wash would be here. Okay. If you need to do it, you uncover it, you put your face there, you push the lever, and it will send water out at such a strong stream, it will peel your eyelids back and wash your contacts out of your eyes, and it does that on purpose. If you need to wash chemicals out of your eyes, we don't want the chemicals trapped between your contacts and your cornea. Does that make sense? Yeah? Okay. Safety shower. I'm not going to demonstrate it because if you pull it again, it'll make a big mess. We do have a floor drain, but not so bezels, so the water will go everywhere. Okay. But if you need to get chemicals off of you, you get the chemicals off of you. Are we good? All right. The next thing on the list, we had eye wash. Yeah, we got that. Shower, we got that. Spilled cleanup materials. Here, nicely labeled. This is a spill control station. That's how we pick up any spilled, especially spilled acids or bases. Yes? Good. All right. We got special absorptive things to do it. All right. The next thing right there, after that, it's, where was I? What number are we on?
It's 6.
6, thank you. Okay, the next is emergency exits. This one is easy. The doors here on the side, those are the doors that are usually used in this classroom, and those are the ones we're going to try to use to get out. Now, if there was a fire in both hallways, we still could get out of this room. We've got some other options. One of them is we could go into the biology room, the biology lab, through that door, go further down the hallway, hopefully past the fire, and go out that way. Another one, I've got a key to go into the prep room. And we could go in there and then into the chemical storage room and then go out that door and we'd be on the hallway at the end of the building. Does that make sense? So we got 4 ways out of here. We should not be trapped. Okay. If we do have to leave for fire, see the big red button? make sure I push the big red button. And if I don't, yell at me and push it yourself. The big red button shuts off every electrical outlet for every table in the room at once and every gas outlet. You would agree if there's a fire, it's not good to have natural gas outlets on the top. Yeah. Okay. Also, underneath the big red button, if you're dealing with fire, we've got a fire extinguisher, yes? There's another safety thing that's not on the list, but should have been. Yeah, you, go ahead. Yeah, there is a fire blanket, as I stumble on, there's a fire blanket here, okay. So, you know the whole stop, drop, and roll, it works even better if you have a blanket that's so thick that it's hard for air to pass through, then the fire dies from lack of oxygen. Okay. There's one other thing, I'm not doing the story because we have to go fast. There's another purpose for this that most people don't talk about. This is a modesty blanket as well. What? Well, if you have nasty chemicals on you, you need to use the safety shower to take them off of you, especially if they're acids. The best way is to get your clothes off first so you don't have acid and water touching each other. And how would you do that with all the other students in there? Easy. You have one student hold the end, I'll hold this end, and you take the clothes off and you wash that stuff off. I'm not exaggerating. There have been cases where people have spilled acids on themselves and they're afraid to take their clothes off to get the stuff off their skin. And they're like, oh, I'll just wash it out. Well, we'll talk for later on why. But acid and water coming together generate really high heats, like boiling water, and it will be like you'll get skin grafts afterwards, kind of bad, okay? So this can be used as a modesty blanket. I've never had that happen for chemical spill reasons. I have, and I can give you the long version later, had a student, I was proctoring a test, and the student fell, they passed out, they shouldn't have been there anyway, they were sick, they decided to come to the test because, oh, I have to be there. If you're coming from the emergency room, you just stay there, we'll accommodate you. They decided, I haven't been seen yet, but I have to go to my test. And they came, they passed out, they fell, they hit their head on the counter as they went down. I'm like, ah! I called 911, they sent the ambulance out with the EMT. By that time, the student was starting to come to, but groggy and all. And the guy's like, I gotta get their clothes off, I gotta get an EKG on them I'm like, this is not a problem. One EMT held a corner, I held a corner. Well, the other student's like, what's going on? I'm like, just keep taking your dang test. And so they were doing their thing, and we did that. Well, a guy took off her shirt and put the leads on and and they're like, we're taking you to the hospital now. And put her on the cart and rolled her out of the building.
Oh, it was a woman, that's what
Yeah,
I'm
it was.
actually. Okay.
It was, yeah. Yeah, probably wouldn't care about taking a guy's shirt off.
Yeah.
Yeah. But the important thing is, they were able to check her and say, yeah, we're taking you to the hospital.
What was wrong with her? COVID, flu?
I don't know.
You never found
Probably have a
out?
heart thing.
It was before the COVID lockdown stuff, so it wasn't
Oh,
that.
okay.
I don't know what it was. It wasn't even when I was in the school, so it was prior to COVID.
Okay.
So, anyway, modesty blanket is a thing. A lot of people don't talk about it. It's a thing. We're moving on. And it's a thing because it's the fire blanket. I would have mentioned here when we're talking about emergency exits, but whatever. Okay, moving on. Check labels twice before use. When a cart is out here with chemicals, it will have a folder with it that is called the MSDS folder, the Materials Safety Data Sheet. You look at any chemical on the cart and you can flip to a page that tells you all the things on how to treat that chemical, what ways it's dangerous, what you should do with that, how you should dispose of, all that information is in the folder. So if you ever have any concerns about what's on the cart, you can look on the folder. Is that good? Is that clear? You got it? Okay. Next thing. If you're in doubt, check for the properties. Yeah. Do not force glass tubing into rubber stoppers. I've seen this one. Actually, I saw glass tubing put into a rubber hose. If you're, we don't have to do that in this class, but you might have to in the chemistry class. If you ever do, take a little bit of soap and put it on the end of your finger, rub it on the end of the glass tube, And then it slides in real nice with the lubrication, because soap's mostly made out of glycerin. If you ask those chemists and they're real all highfalutin, they would say, let me go to the lab prep room and get some glycerin. The soap's glycerin. But lubricate the tube before you try that. If you don't, the rubber sticks to the glass and it doesn't slide in. And I saw somebody, one of my students at that other school, pushing, trying to get it in. And you should be right up there close, but they were back here trying to get glass. And does glass bend real well when it's, no. And they broke it, and then they shoved the jagged edge of the tube through their thumb web and then bled all over my floor. So don't do that. Lubricate the tube if you have to put a glass tube into anything. Good, clear? All right. But in this class, you won't have to. All right. Examine all glassware before use. Do not use chip, cracked, or dirty glassware. I have made that mistake before and gotten my fingertip nicked just a little bit from a piece of glassware. It was an eyedropper. It was right here, this room. It was probably 2 years ago. And when it happened, because of my blood pressure, I'm on blood thinners. I bleed more than most people. So I'm trying to continue the lab, and I'm like this, trying to hold my thumb, put pressure on it, and I'm walking around drip with blood all. It got written up as a mess. So don't use chipped, cracked, or dirty glassware. You can cut yourself even on something that's just a slight little jagged edge. Does that make sense? Yep. Okay. Report all spills and breakage immediately to me. Sweep up broken glass. Here we have dustpan and broom for sweeping up glass, and we have the broken glass container. Oh wow, Heather, our lab manager, is so nice. Usually I like dramatic flourish. Here, all the broken glass, but she actually changed out the liner and changed out the container. It's a brand new one. Start the semester right. So that's where broken glass goes, all right? You do not put it in a normal trash can. We don't want the facilities people cleaning up the trash. So let's be honest, how do you empty a trash can? Normally you remove the liner from the edge, and then you pick it up, squeezing the air out, yes? If you do that and it's got jagged broken glass in there, there's a good chance that you'll be putting broken glass through their hand. We don't want to do that. Does that make sense? So broken glass container, not the wastebasket. Clear? All right. Next one, if you're injured or any type of accident or fire happens, let me know right away. Next one, if you're mixing or eating chemicals in a test tube, do not point it at humans. Sometimes there are reactions that go bleh, and you don't want that to happen. Good, clear? All right. So let's see. Never leave Bunsen burners or other heat sources unattended while in use. It's not like, I have to go to the bathroom. Turn stuff off. You don't want people to accidentally get burned while you're not there to watch it. Does that make sense? Yes? All right. And never use sources of spark or flame, like Bunsen burners or strikers, in the vicinity of flammable liquids. Most organic solvents are flammable. If you're around acetone or petroleum ether or something like that, that's just like working with gasoline. Clear? Good? All right. Back more flammable, sorry. When mixing acids with water, always add acid to water. This is super important. I've heard this done two ways. So a lot of people call it the AAA rule. The AAA rule, always add acid. Other people, the way I learned it, there was like a lab safety poster in our lab, and it had a little cartoon drawing of an otter with lab goggles and a lab coat and all. And it said, do like your otter, add acid to water, But however you learn it, you always put the acid in the water, you never put the water in the acid. The reason is they're different densities. If you put, and you won't notice as much if it's like heavily diluted acid. If you're working with, say, 12 molar hydrochloric, and if you pour it from the concentrated solution into a beaker, you will see that it does not pour like water. It pours a little more like oil. It's thicker, okay? It's also heavier. So here's the deal. If you have a container of water and you pour acid into it, no problem. The acid just sinks in because it's heavier and then diffuses, spreads out. Okay. But if you kept your hands on the container, you would notice it's getting really hot. Because where the molecules of water, molecules of acid are touching, it generates heat. If you did the opposite, you put the acid in first and then put the water on top, the water is gonna float on top of the acid and then spread out across the surface. And then across the whole surface of the container, you have a millimeter or two where they're touching and getting hotter and hotter and hotter and hotter because they're not diluting and spreading out. And eventually it gets so hot the water will boil. And then it will spray boiling acidic water around. And you don't want that. Am I clear? Talk to me later if you want the horse story. We don't have time. Moving on, I have one. I've screwed up with that and it's scary, scary. That's all I gotta say. That was not even at the school, this was long before, but it was, oh my. Like everybody jump away from the sink kind of, oh my. Got it? Yeah, it's bad. All right. When disposing of chemicals, do it like I say. Don't put any solids in the sink because we don't want to clog it with disgusting things. Do not put any liquid waste in the waste baskets because those liners are not designed to hold liquid. It'd be horrible, disgusting, it would leak out, it would be awful. And then it would react with a metal trash can. We don't want that, okay? Check all waste labels twice before adding your waste to a container. Let me explain. Here, we're not gonna deal with really horrible stuff. But if you were in a chemistry class and you're working with stuff, afterwards when you have to throw your chemicals away, there'll be one that is labeled acids and one that's labeled bases. And you put the acid that you work with in the waste acid container. You put the base you work with in the waste base container. If you did the opposite, you're gonna cause nasty things to happen, and if you're lucky, it'll just be foaming out, and it could cause much worse things, you know. Any heavy metal solutions, you'll put in the toxic heavy metals waste. Does that make sense? There will be a container, and it will be labeled for you what to do. All right, let me back up, blah, blah, blah. All right, organic solvents never go down the sink. Waste containers will be provided as needed for their collection. Great. Use fume hoods as directed or when working with highly volatile or poisonous substances. Do you see any fume hoods in this room? All right, that's not us. We're not working with those nasty chemicals. But there are fume hoods next door. Chemistry people use fume hoods. Oh, and here, never place your head in the fume hood. Here's a hint. If that hood is there to suck the badness away, don't say, hey, I want to have some badness, and put your head in the fume hood. Good? Yeah, okay. So we got that. Do not immerse hot glass in cold water as it may shatter. This is just the same as at home. Okay. Do not place hot glassware directly on the countertops. Use an insulating pad. If you look real carefully around here, you will see rings of burned surfaces on the countertops for people to put hot glassware down. It looks a lot like if someone didn't use a coaster and then put a cold glass on top of a wooden table and messed up the surface. Same thing, except it's burn instead of water stain. Does that make sense? Everybody good? Yeah. Okay. Don't do that. Keep laboratory area and supplies clean, store all equipment in proper locations. Wipe down work area before leaving. Remember, you're not the only one in the lab using the equipment. When you're finished with the lab, make sure the cards and lab rooms look the same as they did when you started. That's the end of the rules. You can stop that now.